Once again, my name is Monica Lund, and I'll be talking about the ALUM Crystal Lab. This is the second of 3 videos tracking the progress of my vial's ALUM crystal growth, and it has been a little over 2 weeks since I have performed the experiment. Similar to the first video, there does not appear to be any crystal growth, as the vial solely contains the aqueous solution of alum. Thus, progress of the crystal growth will have to be captured in the final alum video. An environmental factor that is most likely affecting my crystals is temperature. The crystals will form with the evaporation of water, and because the vial is being kept at room temperature, the evaporation of water is happening very slowly. It would be faster if the vial were in a warmer setting. Now we'll transition to discussing calculations behind theoretical and percent yield. These are the 4 key chemical equations that will be used for the calculations. I initially had 1.005 grams of aluminum foil, which has a molar mass of 26.98 grams. After calculating how many moles of aluminum there is, I can use the stoichiometric coefficients of each equation to determine the amount of aluminum product from equation to equation. The ratios of stoichiometric coefficients are denoted by their color coding in correlation to their respective equation. For example, in the red brackets, this information correlates to this red equation. So for 1 mole of aluminum ion, there is 1 mole of alum. This happens for each of the different colors. All of this information is multiplied together. Finally, we multiply by the molar mass of alum to calculate its theoretical yield, which is 17.67 grams of alum. In order to calculate percent yield, we divide the actual yield by the theoretical yield. The actual yield was 19.161 grams of alum, and the theoretical yield was 17.67 grams of alum, as we calculated before. Our percent yield thus is 108.4%. A perfect lab scenario would have a percent yield of 100%, where the actual yield is precisely what the theoretical yield predicts. My large theoretical yield of 108.4% can most likely be attributed to 2 possible errors. A, the impurities were not entirely filtered out, which contributed to the mass of the product, and/or B, the alum was not entirely dry when we massed the alum at the end of the experiment, and the water contributed to the mass of the product. Stay tuned for the final video.